Good morning, our students, and welcome to this morning's discussion. Today, we want to look at a topic titled Sampling Distribution of the Difference between Two Sample Means, where sampling is done with replacement. So, there are two key words in this topic. One is difference, and the other is with replacement or replacement. So we are going to look at this topic now by considering two populations. And I call that two populations, population 1 and population 2. So I have population 1, I have population 1, population 1. And I equally have what? Population 2. Population 2, population 2. And let me say that there is a variable of interest x. And that variable of interest x in the population follows a particular distribution. And that distribution is given as that a random variable what x follows a distribution. Permit me to write distribution this way with parameters what mu 1 and then sigma squared what 1. I close it. We are talking about a population 1, and that population 1 is concerned with a random variable x. And that random variable x follows a distribution that has mean mu1 and variance sigma squared what 1. And then let me tag this one x1, that random variable x1. I equally come to this population 2. I have x what 2, which follows a distribution. It follows a distribution with parameters what mu2 and then sigma squared what 2. I then close it. So this population 2 is also concerned with x2, which is a random variable that follows a distribution with parameters mu2 and then sigma squared 2. That is, the mean is mu2, which we call the population mean, and then the population what variance is sigma squared what 2. Now, we are going to take a sample from this random variable x1. We equally take a sample from this random variable what x2. And these samples we are going to take from these two populations now are going to be of a fixed size. So I'm going to talk about what a sample here, talk about a sample here, talk about sample. The size of this sample is going to be what? N1. Each time I'm taking this sample from this population. So I equally talk about what? A sample. And then this sample is going to have a fixed size what? N2. Each time I'm going to take sample from this population x2. Then now we now talk about what the samples. I am going to take different samples from population 1, and each of the sample is going to have a fixed size n1. I am going to take different samples from population what 2, and each of the sample I am going to take is going to have a fixed size n2. Let me say I have sample numbers. The number goes this way. I have 1, I have 2, I have 3, down the line. Then if I take a sample, the first sample I'm going to take from this population 1, I am going to compute what? The mean of that sample. And if I compute the mean of that sample, I am going to denote it with what? X bar 1. X bar 1 here is talking about the mean of the sample that I took from population 1. I equally come here, I take the first sample, and from that first sample I've taken, I am going to compute the mean of that first sample. And when I compute the mean of that first sample, I am going to write what? X what bar what 2. Then I equally return back here. I take the second sample from the first population, and I'm going to equally compute the mean called x bar 1 as well. The same thing is what I'm going to do here. I am going to take that sample and I'm going to call it what? X bar what 2. I return back here, I also do the same thing and I have x bar 1. Here I am equally going to have what? X bar what? 2, and then it continues down to any possible sample I am going to take from the respective populations. And of course, we should bear in mind here that we are taking this sample with replacement. That is to say that each observation that is included in our sample is returned back to the population before we draw the next one. That is what we call sampling with replacement. The concern here is that we have now three different distributions here because we are done taking samples from population 1, we are done taking samples from population 2. From each of the sample drawn from the population 1, we are done computing the mean of the samples. From the samples drawn from the population 2, we are done computing the means of of the sample. And our interest here is on the difference between the sample means. So we are going to consider the difference of these sample means. So the first one here, I am going to have x bar 1 minus x bar 2. It is going to give me a value here. Then I equally come here, I am going to have for this sample number 2, I'm going to have x bar 1 minus x bar 2. It is equally going to give me a value here. Then I equally come here, I have x bar 1 minus x bar 2. It is going to give me a value here for the sample number 3. And I'm going to continue it this way, say up to 100 times, 200 times, or any number of sample that I am interested in. One thing is important here to note. Now, this x bar 1 computed from the first sample, x bar 1 here computed from second sample, x bar 1 here computed from third sample. They are going to vary from sample to sample. They might not be the same thing. If they are the same thing, they become constant. But they cannot be the same thing because you are drawing random sample. Because the samples are random, not the same values that they are taking from the population. Equally, the means will keep to change from sample to sample. And because they are not constant, they are changing from sample to sample, they form a distribution. And of course, the distribution they are going to form is equally going to have their own parameters. That is the mean and then the variance. The same thing applies here. They are not constant as well. They keep to change from sample to sample. They equally form a distribution. And we will be interested in the distribution or in the mean and the variance of that distribution. The same thing applies in the difference between the sample means. This difference here, this value here, will keep to change from sample to sample, and they equally form their own distribution. So our interest this morning is in the distribution formed by these sample means, distribution formed by these sample means, and then the distribution formed by the difference between these two sample means. And of course, we earlier had said that our sampling is for with a replacement. So if sampling is for with replacement, the distribution of the sample means is known to be that our x bar 1 follows a distribution. It follows a distribution with mean mu 1 and then variance sigma squared 1 all over n. Then we close the brackets. And that n is what we call n1, talking about the sample size. The same thing applies here, that the distribution of x bar 2, that x bar 2 follows a distribution. It follows a distribution with mean mu 2 and then variance sigma squared 2 all over n 2. You close the brackets. With this, it can be established, or it is established, that when we come to a population that has mean mu1 and variance sigma squared 1, and then we take samples, and from the samples drawn from that population, we compute the means of what? Of the samples. The means equally will form a distribution. And the distribution that the mean is going to follow is going to be mu1, the same thing with the mean of what? Of the population. But the variance is going to be different. The variance of population here is sigma squared 1, while the variance of the population, the variance of the sample mean here is sigma squared 1 all over n1. The same thing applies with what? With population 2. From population 2, draw different samples of the size n2. From the samples now, compute the means of what? Of the samples. The distribution of the means of the samples is going to be mu2, the same thing with the mean of what? Of the population. But the variance is going to be different, or the variance are different. The variance here, which is now the population of what? The variance of the population is sigma squared of 2. Then the variance here is sigma squared of 2 all over n2. So we are now going to use the distribution of x bar 1 and then the distribution of x bar 2 to determine the distribution of the difference between x bar 1 and x bar 2. So that is our major interest. So you permit me to clean the topic while we now talk about the distribution of x bar, the difference between x bar 1 and x bar 2. So permit me to clean here. Permit me to clean here. We have established that, of course, the difference of this distribution is equally going to follow a distribution because they are not constant. They are changing from sample to sample. And our interest is, what are the parameters of this distribution? Parameters in terms of the mean, in terms of the variance, and perhaps in terms of the shape of that particular distribution. And when we want to do that, we now see that our x bar 1 minus what? X what bar what? 2 is going to follow a distribution. Is going to follow a distribution. And that distribution is going to contain mean, and then it's going to contain variance. So how are we going to determine the mean and then the variance? Look at how we are going to determine the mean and then the variance. Now, if sampling is with replacement, we have known that the distribution of x bar 1 is going to be this way, and the distribution of x bar 2 is going to be this way. So now, the variance, the mean of this x bar 1 minus x bar 2 is going to be written this way. It is going to be E of x bar 1 minus what? X bar 2. This is what we call expected value of x bar 1 minus x bar 2. And when we talk about expected value, we are talking about the mean of a random variable. And we are told that each time we have expected value, a bracket, in an expression into it, we can use that expected value to open that bracket. So this thing becomes what? E of x bar 1 minus what? E of x bar 2. And then we have known that the expected value of x bar 1, which is the mean of x bar 1, is given as mu1. So this thing becomes what? Mu1 minus. We have known that expected value of x bar 2 is the mean of x bar 2. And then the mean of x bar 2 is what we have here as a mu2. So we have minus what? Mu2. Meaning that the mean of the difference between two means coming from two different distributions is given as mu1 minus what? Mu2. So we now talk about what? The variance. So you permit me now to clean here. We talk about the variance. When we talk about the variance, we are told that the variance is written this way. We have var of what? X bar 1 minus what? X bar 2. This is going to be var of what? X bar 1 plus var of X bar 2. As long as the sampling is with replacement. Okay? because the covariance term here, of course, we have the covariance term is going to be what? To be 0. What are we going to do? We now come here and say this is given as. We are aware that the variance of x bar 1 is given as a sigma squared 1 all over n1. So here it becomes a sigma squared 1 all over n1 plus variance of x bar 2 is given as this. So we have sigma squared of 2 all over what? N what? 2. So each time we are told to find the mean of the distribution of the difference between two sample means, it is given as mu1 minus mu2. We are told to find the variance of the difference, of the distribution of the difference between two sample means. It is given as sigma squared 1 all over n1 plus sigma squared 2 all over n2. We can equally talk about the standard error of the means. The standard error of the means. When we talk about the standard error of the means, of course, standard error of the means is the square root of variance. So this is square root of var of x bar 1 minus what? X bar what? 2. Which is the same thing like saying square root of var of x bar 1 plus var of x bar what? 2. Close the bracket. Which is the same thing. We have got everything here to be this, so this will become square root of sigma squared 1 all over n1 plus sigma squared what? 2 all over what? n2. This is what we call standard error of the mean. Standard error of the mean. Standard error of the mean. So if you talk about the standard error of the mean, for the distribution of the difference between two sample means, this is what you are going to use to compute it. And at times, let me mention something. At times in textbook, these things which are written here, they can equally denote it to be mu of x bar 1 minus x bar 2. This is the same thing as mu1 minus what? Mu2. This way. So it is either they represent it this way, or they represent it this way, or they represent it this way. They equally can call this variance here. They say sigma squared what? Sigma squared of x bar 1 minus x bar what? 2. This is the same thing as sigma squared 1 all over n1 plus sigma squared what? 2 all over what? N what? 2. So it can be written this way, it can be written this way, and it can be written this way. The most important thing that whichever way it is written, the expression is given to be this way. It can be written this way, it can be written this way, it can be written this way. The most important thing that whichever way the expression is given this way or this way. Okay? And then when we now talk about the standard deviation or the standard error, it becomes what? Sigma alone x bar 1 minus x bar what? 2, which becomes the square root of sigma squared what? 1 all over n1 plus sigma squared what? 2 all over n2. So summarily, when you are talking about the mean of the distribution of the difference between two sample means, it is the mean of the first population minus the mean of the second population. Mu1 minus what? Mu2. If you talk about the variance of the distribution of the difference between two sample means, you are talking about then the sum of the ratio of the variance of the fourth population all over the sample size coming from population 1, and then plus the variance of the population 2 all over the sample size coming from population 2. And then when you talk about the standard error of the mean, which some people can call the standard deviation of the means, then it is the square root of the variance, which is what is given this way. So we are going to look at one or two questions coming from this. So you permit me to clean here. Let us look at the question here. The question we have here says, the question says, okay, two populations have the following parameters. Two populations have the following parameters. Two populations have the following parameters, and those parameters I have are, we have that mu1 equals, mu1 is given as 100, sigma 1 is given as 15, n1 is given as 25, mu2 is given as 120, sigma 2 is given as 20, n2 is given as 36. n2 equals 36. They say find the mean of the distribution. So find mu of x bar 1 minus what? X bar what? 2. And we equally should find what? Sigma squared of x bar 1 minus x bar what? 2. And then we should find the last but not the least, the sigma of x bar 1 minus x bar what? 2. That is, we should find the mean of the distribution of the difference between x bar 1 and x bar 2. We should find the variance of the distribution of the difference between x bar 1 and x bar 2. And we should find the standard error of the distribution of x bar 1 minus x bar 2. And of course, we still have the answers on the board. The first one says that the answer is mu what 1 minus what mu 2. So we quickly go and look at our mu 1. Our mu1 is 100, and then our mu2 is 120. Okay, so we now say that this thing becomes what? 100 minus what? 120, which of course gives us what? 20. Minus 20, sorry. Gives us minus 20. So the next one is for us to find the variance. We still have the formula of our variance here on the board, which says that this is sigma squared, that this is given as, this is equals to sigma squared of 1 all over n1 plus sigma squared what? 2 all over n what? 2. This is equals. We can look for sigma squared 1. We are not giving sigma squared, we are giving only sigma 1. But when we square it now, we have to square the 15. So it is going to be 15 squared all over. So here becomes what? I have 15 all squared all over. I'll go and look for n1. My n1 is 25, so I have all over 25 plus. Here is sigma squared 2. So I'll go and look for sigma squared 2. Sigma of 2 is 20, so I need to square it. So it becomes 20 squared all over n2. Where is my n2? My n2 is 36. So this thing becomes 36. And once you evaluate this, it gives you the answer. The other one is just for you to take, the last one is for you to take the square root of whatever thing that you get from here. So that is now what we mean by sampling distribution of the difference between two sample means. We are quickly going to say something, and what we are going to say is, what if now we happen not to know the population standard deviations? Assuming we do not know the population standard deviations, what are we going to do? So let me quickly clean here and show us what we are going to do when we do not know it. When we don't know the population standard deviations, sigma squared 1 and sigma squared 2, that is, we have that our x what 1 follows a distribution, and that distribution is mu1 comma, sigma squared of 1. Then we have another one. We have x what 2 follows what a distribution with what mu what 2 and then sigma squared what 2, like we earlier had said. We are saying in a situation whereby we don't know this sigma squared 1 and we don't know the sigma squared 2. And we are still interested in the distribution of the difference between the sample means. What are we going to do? That is our concern. If it happens that way, what are we going to do? What we are going to do is this. When this sigma squared 1 and sigma squared 2, they are not known and they are assumed to be unequal, that they are not equal. So we are going to look at two cases. When they are assumed to be what? Unequal, they are unknown and assumed to be unequal, and then they are unknown and assumed to be equal. What are we going to do? So case one, in that case one, we are talking about when they are unknown and they are assumed to be unequal. In that case, we are going to say that our sigma squared of x bar 1 minus what? X bar what? 2 is going to be given as, we have what we call s1 all squared all over n1 plus what? S2 all squared all over what? N2. That is to say that when we do not know this and we do not know this, we replace them with the sample variances, S1 squared and S2 squared, as long as they are unknown and they are assumed to be unequal. And in that case, we are saying that our sigma again becomes x bar 1 minus x bar what? 2 should now be given as square root of S1 all squared all over N1 plus S2 all squared all over N2. While the mean remains the way it is. The mean is going to be that our mu of x bar 1 minus x bar 2 is given as mu 1 minus what? Mu 2. This is in the case 1 when they are unknown and assumed to be unequal. However, when they are unknown and assumed to be equal, we have case 2. And in that case too, our variance is going to be sigma squared of x bar 1 minus x bar 2 is going to be given as what? We have SP all squared, which we call the pooled sample variance. The what? Pooled sample variance into 1 all over N1 plus what? 1 all over N2. Close the bracket. We now say where this our SP all squared is given as N1 minus 1 S1 all squared plus, open a bracket, N2 minus 1 S2 all squared all over N1 plus N what? 2 minus 2. So anytime we have this information that the two population variances are unknown and they are assumed to be equal, this is the expression that we are going to use to compute the variance of the distribution of the difference between the two sample means, x bar 1 and x bar 2. So if someone asks us now to get the standard deviation is going to be sigma of x bar 1 minus x bar what? 2 is going to be, I am going to take a square root of this. And when I take a square root of this, what I have becomes square root of what? SP all squared into 1 all over N1 plus 1 all over N what? 2. Close the bracket. And of course, look at this thing inside, which is squared. So I can bring it outside this square root sign. So this thing becomes SP, then square root of 1 all over N1 plus 1 all over N what? 2. And this time around, this our SP now is going to be that our SP now becomes square root of. You now say n1 minus 1 s1 all squared plus n2 minus 1 s2 all squared all over n1 plus n what 2 minus what 2. So this is how you are going to handle it when you have this information that they are unknown and either assumed to be unequal, the first one, or they are unknown and assumed to be equal, the second one. Okay, let me now show you this question and ask you to try to see whether you can compute it on your own. So you permit me to clean here, or let me read out that question here. See the way that the question goes. See the way that the question goes. Okay. See the way that the question goes. The question says, sample 1. The question talks about sample 1. So let me clean here the top. Talks about sample 1. It says n1. It says n1 equals 25, comma. X bar 1 equals 10. X bar 1 equals 10. S1 equals 4. N2 equals 16. N2 equals 16. X bar 2 equals 7. 7. And then we have that S2 equals 3. S2 is equals what? 3. So the question here says we should calculate the variance and then the standard error of the mean. They say we should calculate the variance and then the standard error of the distribution of the difference between two sample means. They gave in a case 1, when sigma 1 squared and sigma 2 squared are unknown and assumed to be unequal. And case 2, when they are what? Unknown and assumed to be equal. Now we quickly show something. The first one says that they are unknown and assumed to be unequal. We still have the formula here on the board for us to get the variance and get the standard error. So here is our S1 squared and we are giving S1 to be 4. So it's just for us to come here and say our 4 squared. So here becomes our 4 squared. Here is what? 4 squared all over. My N1 is 25 all over 25 plus. Here is my S2 squared. S2 is given as 3. So I have 3 squared all over. N2 is given as 16. So this will give me that for the variance. So if I want to get the standard error, I will now take the square root of whatever thing I'm going to get here. In the second case, they say they are unknown and assumed to be equal. In that case, you come over here. So before you can do anything, you first of all go and compute this your pooled variance. And for you to calculate this your pooled variance, look at the formula here. N1 minus 1. And your N1 is what? Is 25. So 25 minus 1 into. Your S1 squared is 4 squared here plus. N2 is 16 minus 1. Here is 3 squared all over this. You evaluate this. Once you evaluate this and bring it here, it becomes this quantity which are evaluated into 1 all over 25 plus 1 over 16. Whatever thing you get becomes the variance of that. And for you to get the standard words error, you take the square root of whatever thing you get. And that arrives you at the answer. Thank you for your audience this morning as we look forward to going to have the sampling distribution of the difference between two sample means when sampling is done for without replacement. What we do today is when sampling is done for with replacement. You are going to see that there is going to be variations in the formulas that we have shown today when we are considering that when sampling is for without replacement. Reason being that we are going to introduce what we call the finite population correction factor, when we are discussing when sampling is done for without replacement. Thank you, and then stay connected. Do not forget to subscribe to our YouTube channel and follow our classes.